Alright, say hi. Alright, hopefully that's not muted. That'll make this pointless. Alright, so I'm recording this one because you might have a problem like this as a bonus. Alright, and we did one of these the other day, and then if I upload it to YouTube in a timely manner, you might be able to use it to study. But also because a lot of people have trouble on the word problems, and I'm going over 2 of those today. So, the first one, who was it? Jessica. Jessica suggested that C plus B equals A. And I know that was random, but she was absolutely right. Because what we do to solve this kind of problem is we let C plus B equal A, and temporarily, you know what, I want to use some green here. We temporarily replace that term with this. And where the problem up here is one that I probably wouldn't give as a problem on the general test, you know, I would give it as a bonus. This problem absolutely could be a regular problem because we've done enough of these now, right? We recognize that this is a what? A perfect square, and this too, because it has an even power, is also a perfect square. And so when we have a difference of perfect squares, it factors into a conjugate pair composed of the square roots, right? So what's the square root of this guy here? A squared. And the square root of 81? So I'm going to write the plus term first. And why do I always write the plus term first? Yeah, because the plus term, unless it's broke into a difference of cubes or a sum of cubes, the plus term generally doesn't break down again as often as this one does. The minuses do more often because a minus will break down further if this is a difference of cubes or a difference of squares. Which do we have here? Yeah, we have a difference of squares. This is a perfect square. This is a perfect square. This is a sum of squares. SOS. What's that? Nothing. DOS. Yeah, that's something. All right. Difference of squares factors into same thing, conjugate pair composed of the square roots. So you get this and this. Now this is where it becomes back to the bonus problem. All right. This green part I would expect you to be able to do. I don't know that you can tell it's green on there, but when you watch the video I hope that you will. But this part right here, that's just a regular problem from this chapter. Once I plug this junk up here back in, now it's in the realm of bonus. All right. So I put the C plus B back in. I put the C plus B back in. I put the C plus B back in. And this part here is fine. This part here is fine. I can't do anything more with those. But I generally don't want to leave a binomial squared inside a term. I want to square it out and write it long form. So to square a binomial, we would do C plus B times itself. And the reason I'm saying this is sometimes if it was C plus 2, we would have a 4 at the end, and that 4 would combine with a 9 and make a 13. So you normally want to square this out. This will be C squared. You'll have a BC on the inside. You'll have a BC on the outside. So how many BCs will you have? 2 BCs. And you have 1B squared. Because I like BC because I'm going to correct the order in a minute anyways, and we normally write, when we have products of variables, we normally write the variables in alphabetical order. And so now that's my result there. There's no like terms, but I can write it, and this is optional, because if you have one of these in my math lab, it doesn't care what order you write the terms of addition in. Okay, so you can write it in this, leave it in this order, or write it in this order. And then let me bring down this stuff. And let me write this in the preferred order. So this part up here, standard question. The rest of this, you can see how involved it is. All right, so that would be something I'd give as a bonus. Make sense? Okay, here's 2 more problems that you can try on your own if you'd like. So pause now, and you can see the answers in a little bit when you unpause. All right, here's the answer to the first one. It's not crazy hard. Nice simple substitution. There you have it. Pause if you need to. Okay, here's the second one. It's pretty involved, so pause it near the end so you can see all the steps and check your work. I hope you had fun. Bye-bye.